So now we need to try to get what our revenue look like if we have allocated 0 gallon of milk to store 1, allocate 1 gallon of milk to store 1, or allocate 1 gallon of milk to store, allocate 2 gallons of milk to store 1, or allocate 3 gallons of milk to store 1. So if, let's start with the first one, if you allocate 0 gallon of milk to store 1, the revenue is still what? $0. So it will be $0. Then if you allocate 1 gallon of milk to store 1, it's still what? $2 per gallon, because I'm making $2 for 1 gallon. So if you allocate 1 and there's a demand of 1 from the customer, you're going to get $2. So, but when you get to 2, that's when you need to go to your probability 2 going upward. So don't forget. So now, if you allocate 2 gallons of milk to store 2 and there's a demand of 2, you allocate 2 gallons of milk to store 1, then what will our expected revenue look like? That's when you need to go to your store 1 probability information and factor that in, take into consideration all the chances of the demand that you could have. So if you do that, you see that the revenue for allocating 2 gallons to store 1, the expected revenue will look like the probability that you have a demand of 2 or more gallons of milk is what? 0 plus 0.4, which is 0.4. So that will give you 0.4, 0 plus 0.4, because probability of 2 or more is 0 plus 0.4. It's 0.4. And if there is 2 or more demand, and you have allocated 2, that means you are going to sell all the 2 you have allocated. 2 gallons that you have allocated, and you're going to make a revenue of what? 2 times 2, which is what? 4. And that is what you are seeing here, which is 0.4 times what? 4 plus, there is a probability that, so don't forget, the allocation is 2, and the demand is, in the next case now, the demand is, we have looked at the demand being 2 or more, so we are going to sell 2 or more. Yeah, that is the one that gives us this, because if it's 2 or more, that means we are going to sell all the 2 allocated, and the probability of having that is 0 plus 4.4, which is 0.4 times 4. Explain that. How about if the demand is 1? If the demand is 1, there is 60% chance, which is 0.6% chance that the demand will be what? 1, so which is 0.6. So if demand could be 1 and there's 60%, then what would our revenue look like? The revenue would be the demand. What is the money you're going to make for selling this 1 gallon? So that is 1 gallon. For selling 1 gallon, you have $2. Then the remaining 1, because you have allocated 2, the remaining 1 you're going to sell it back to the dairy at 0.50 cents, which is $0.5. So that's how you get 2 plus 0.5, which is 2.5. That's how you get 0.6 and 2.5. So that's how we got this expression. Just explain how you got it. So if you simplify it, that will give you 3.10. So that will be the revenue you are going to get, if expected revenue you are going to get if you have allocated 2 gallons of milk to store 1. How about if you allocate 3 gallons of milk to store 1? So if you allocate 3 gallons of milk to store 1, let me show you the expression of how I got that. 3 gallons of milk to store 1. So it means that in this case, if the demand could be 1, if the demand could be 3, there is what? 40% chance of having demand to be 3, which is 0.4, and that means there is there is 40% chance of having a demand to be 3, and the revenue you are going to get if the demand could be 3 is 2 times 3, which is what? 6. That's how we get 0.4 times 6, which is here. And plus, how about if the demand could have been 2 and you have allocated 3, there is 0% chance that demand will be what? 2. So which means that you have 0% chance that demand will be 2. So if you have got that, so you are going to sell these 2 for $2 a gallon. That will give you 4. Then the remaining one you sell it back to the dairy, which is 0.5. So that's how we get 0 times, this is 4 times 4 plus 0.5, which is 4.5. So that's how we got 0 into bracket what? 4.5 that you have here. And it's very clear now. then if the demand could have been 1, then in that case you have a 60% chance. If the demand could have been 1, you have a 60% chance that the demand will be 1, which is 0.6. And if the demand could have been 1, then you only sell 1 gallon for $2, so that would be 2 plus the remaining 2, you sell it back to the dairy at 50 cents per gallon each. So that will give you 2 times 0.50 cents, and that will give you 1. So that's how we got 0.6 into bracket 2 plus 1, which is 2 plus 1. 2 plus 1 will be equal to what? 3. So that's how we got 0.6 into bracket what? 3, because that's how we got 0.6 into bracket 3. You can see it here. So based on that, now if you simplify this further, the expected revenue would be what? 4.20. So it means that if you have allocated 3 gallons to store 1, your expected profit or revenue will be what? The expected revenue will be what? 4.20. Now, since we have known all the possible revenues that we can get, depending on each of the allocation that we can allocate to either of the store, then we can proceed to what? Stage 2, because we need all these revenue solutions in our stage 2 computation and stage 3 computation. So I'll go to the stage 2 computation now, and we'll be able to get it. So I'm going to